Nope. I want to just refresh everyone's memory of our quadrilateral tree. We have spent a lot of time already on the parallelogram. Now today we're going to turn our attention to the rectangle and the rhombus. There is a reason that these two are down below the parallelogram. Remember, every single day I've had you guys list me 5 properties of a parallelogram. Well, these two are below because they also have those properties. So those 5 properties we listed off every single day with me, the rectangle and rhombus have, with some additional ones you're going to learn now. All right. So before I move on, a rectangle is a parallelogram. A rhombus is a parallelogram. But I cannot say what? A parallelogram is a rectangle. I cannot say a parallelogram is a rhombus. But I could say these two are parallelograms. All right. So let's start it off with, what do I have first? The rectangle. All right. Here's the deal with the rectangle. If you have a parallelogram and you put one right angle in it, it becomes a rectangle. Okay? If you have a parallelogram and you put one right angle into it, it becomes a rectangle. All good? Okay? Notice what the first 5 properties I gave you were. These are all the what? Read through them. These are all our parallelogram properties. They all apply to the rectangle. Never forget the parallelogram properties. They still apply. What are the extras? Here they are down below, 2 and 3. In a rectangle, all the angles are right angles. Okay? All the angles are right angles in a rectangle. That does not happen in a parallelogram, only in a rectangle. And a little something extra about the diagonals now. They are congruent. They're equal in length. Now, I would like you guys to put the two together here. They're equal in length, and they bisect each other. Can you tell me anything about the 4 pieces then that are formed when they intersect? They're congruent, and they bisect each other. They cut each other in half. What can you tell me about each individual piece now? They're all congruent to each other. Yep. All 4 are congruent. That does not happen in a parallelogram, just the rectangle. And that leads me to what you are going to write down for me. I'm going to put a 4th property in now. Because all 4 are equal, what do you know? What type of triangles do I have? I have 4 isosceles triangles. So here's our 4th property. The diagonals form 4 isosceles triangles. Why is it important to know that? What's across from those congruent sides? Yeah, so if for some reason you're stuck, remember, hey, they're isosceles, so these 2 are equal. Those 2 are equal right there. Okay, if you're ever stuck because they're isosceles. Questions? So there's the rectangle. Ready for the next one? Rhombus. All right. Okay, there's a parallelogram. What makes it into a rhombus? Ready? 2 consecutive sides being congruent. If you have a parallelogram that 2 consecutive sides are congruent, you have a rhombus. Now think about it. What did you know about the sides of a parallelogram? Opposite sides are congruent. I just told you in a rhombus, consecutive sides are congruent. So what do you know about all 4 then? Oh, yeah, they're all there. It is right there. Number 2, all sides congruent in a rhombus. And diagonals. Here we go. Drawing your diagonals. They're pretty powerful in a rhombus. A lot of properties piling up. I understand. Welcome to Enriched. First property. Diagonals bisect the angles they're drawn to. So what's bisect mean? Cuts it in half. 2 equal parts, right? So these 2 are congruent. Those 2 right here are congruent. Not all 4 though, but those pairs are congruent because the diagonal cuts it in half. And number 4, the diagonals are perpendicular, which means they form right angles. So here you go. Diagonals perpendicular. And that'll come into play, you'll see at the end of class when we do our last algebra problem. Keep though, you're going to have to flip back and forth here because now it's going to go rapid fire. I'm going to go around the room calling on people, applying our properties. So let's, if you have a calculator out, if you haven't gotten it out already, let's do it. All right. First question, these are all parallelograms. All 4 diagrams are parallelograms. I've added some markings. Give me a better name than parallelogram now. Okay? All 4 of those are parallelograms. I put a couple markings on them that makes them into new figures. Give me a better name right now. So number 1, here's a parallelogram. I put in a little marking there. What is the figure now? Here we go. Let's go. Oh, maybe not. Here we go. We know how to do it then. Who wants to start? What does Justin go?
Rectangle.
Rectangle. All right, so if we need to flip back and forth to our rectangle properties, but still remember it's a parallelogram. I don't care what angle you give me, what order you give me it in. Even if it's not a numbered angle, I don't care. Find an angle right now in that rectangle. Find an angle for me. Knowing that, we're going to start off with this angle's 18. Where do you want to go from there? Justin, need somebody. Oh, actually, never mind. 5. Who's got 5? All right, here we go. Any angle or even an unnumbered angle. I don't care. Remember, it's a rectangle and a parallelogram. So if that's 18, go from there, Mike.
That's 18. Then that would mean that the angle that is directly next to it somewhere.
Mm-hmm.
Let's see here. Angle. I don't know.
You're pointing to this one, or?
No, I don't know.
Okay.
I don't know.
It's still a parallelogram. When you have a diagonal drawn in any type of parallelogram, what did we say we need to look for? What type of angles do I have up here, Mike? What do you know about them? So name me an angle you know now. Angle 3 is 18 degrees. Diagonals will form alternate interior angles every time. All right, that's 18. Great. Next up. 8. And I'll go for anything. I don't care if it's numbered or not. I got angle 3 is 18.
The angle beside 18 is 72.
This one right here?
Yeah.
Yep. They're complementary because you know what are the angles in our rectangle, Nick? All right angles. Okay, that's fine. Thanks. I'm sure it'll help us sooner or later. Next up, 12. Another angle up here. We're here? Oh, here? Yep, because they're alternate interior. All right, fine. We'll get to a numbered angle sooner or later. Here we go. Okay, Emma needs somebody. Guys, look at the rectangle properties I had you write down, please. There was one I added in there. What was the one I added in? That these are 4 what type of triangles up here? Isosceles. What's across from the congruent sides? Congruent angles. Can anybody tell me what angle 1's going to be then? 72. Okay, now that you know that, this should be clear sailing now. Clear sailing. Hopefully. 10, go. 10, need something.
Angle 2 would be 36.
Because?
You add up the 72 and subtract from 180.
Perfect, 36, done. Next up. Go ahead, Luke, need somebody.
Sean.
Go.
Angle 4 is 144.
Angle 4, 144, how do you know?
180 minus 36.
Linear pairs are supplementary. Yes, Emily, what's up?
Never mind, I figured it out.
Okay. And then how about angle 3 now? 11? Up. Perfect. Hey, pick somebody. Nope. Okay. Nope, 12. There we go. 18. How'd we get it? Alternate interior with the 18 I gave you. It's also complementary with the 72 because it forms a right angle. We all good there? All right, let's keep moving here. One's definitely not going to make us great. 2. What type of figure is it now? It's a parallelogram with a little extra I added in. Makes it a what? 1? Makes it a rhombus. Thank you. Why? Because a parallelogram with consecutive sides, congruent, makes it a rhombus. All right, so everyone take a peek at your rhombus properties. There's a lot going on here. And remember, we just called it a rhombus. It's still a parallelogram. All right, don't forget about that. It's a parallelogram. Anything you want to tell me up here? 4? There we go. Boom. Why, Rachel? Diagonals are perpendicular. They form a right angle. Great job. Moving on. More angles. Go ahead, Rachel. Up 15. There we go.
I said angle 3 was my.
Darn right it is. Diagonals are perpendicular. We're on a roll. Just need 1 and 4. 4. Look at that other. Look at what else the diagonals do in a rhombus. That'll help you out. They're perpendicular and. Okay, so tell me something now. If they bisect the angles. There you go. 59 degrees. All right, we are working our way up to angle 1 now. Working our way up. 8, what do you got for me?
59.
It is 59. If anybody, go ahead. I'll let you just, it's your 59. Go ahead.
Alternate interior with that other 59.
It's alternate interior with that 59. And remember, hey, take a look. Remember, what do you know about opposite angles? It's a parallelogram. What do you know about opposite angles? Congruent. So if I cut that one in half, these are getting cut in half the same way, 59 and 59. Woo! All right, 3. Anybody notice any markings on 3? Me neither. So I can't call it anything yet other than a parallelogram. And I'll stop right there. It's a parallelogram. We're not ready to name it with a rectangle or rhombus yet, but since it is a parallelogram, can you tell me any angle measurements? Who's the last one to go? Go ahead, need somebody. Okay, Justin. Angle 1 is 60. Tell your classmates how you got it. Alternate interior, yep. All right, can we stop right here? Can you guys name what type of quadrilateral it is now? It is a parallelogram. That's 60 and that's 30. What type of 10? What type of parallelogram is it? Rectangle. Okay, help me with the other angles then. 18. What else do we have? Angle 4 is 30. Let your classmates in. How do you know that? There you go. 4 isosceles triangles. That's 30. Next up, any other angles you want? Hugh, go ahead. Pick somebody. Angle 2 is 30. Why? Bunch of different ways, but I just want to hear one way. Alternate interior with the 30 I gave you. Yep. And then now we're down to angle, what, 3? Okay. Angle 3, number 6. Sean, go ahead.
60.
60. Why? One reason why.
Because the angles are 90. So.
30 and 60, yep. Questions? And let's get to 4. What type of angle, what type of quadrilateral is 4? 18, what type of quadrilateral is 4? What is it? Rhombus. Why? Because it's a parallelogram with consecutive sides congruent. All right, go to your rhombus properties, everybody. We are moving. Hugh, go ahead. Need somebody. Angle 4 is 90. Diagonals are perpendicular. Another angle for me. Go ahead, Max. Pick somebody. Emma, need another angle. Angle 2 is 68. Again, the diagonals bisect the angles, so 68, 68. I'm not going to give away the other parts, though. We just gave up, it looked like. All right, Emma needs somebody. 3 is 68. Diagonals bisect the angles. And now it looks like the only thing I need is angle 1. Go ahead, need somebody. I'm just asking. Yeah. Yep. Yep. Okay. Just asking. Everyone good? Yeah. Okay, so that takes care of basically all the angles. Now let's talk about the side lengths now. Side lengths. Here we go. Go ahead, set up a diagram. You got a rectangle here. You guys remember how we label any quadrilateral? Start anywhere, but have to go clockwise or counterclockwise. Can't jump diagonally, remember. That's any quadrilateral we talk about. So wherever you want to start, but just make sure you go clockwise or counterclockwise. And it's talking about HJ and KI. What are those we just drew in? Diagonals. Okay, so if you got to go look back, what should I know about the diagonals of a rectangle? Who just answered? Go ahead, Cameron, need somebody. Diagonals of a rectangle? They do? And they're all congruent. So what should I be doing with this 3x plus 5 and this 5x minus 9, Amy? Diagonals are congruent, so 3x plus 5 is equal to 5x minus 9. I'll wait till you guys finish that up and let me know the value of x. Go ahead, Amy. Go ahead, yeah. Go ahead, Amy. I need somebody. 7, yep. Make sure you guys answer the question. It said find x, then find the length of each diagonal now. So I'll give you another second or two. IK, HJ. Go ahead, Heaven. Need somebody. Yep.
And then the second one is
Hopefully they're equal, right, everyone? Hopefully they came out to be the same because the diagonals are congruent. All right, this one's going to be a little bit tougher. It's a rhombus. What's GI? They tell me is 8. What is GI? Okay, diagonal, and what's FH that they tell me is 6? Okay, so they gave me the values of the diagonals. So go back if you need to. What's so special about the diagonals of a rhombus that may help me out here? Diagonals of a rhombus. They do a few things. 19, one thing they do. They bisect the angles. All right. Are we talking about any angle measurements, though? Okay, so still true. Probably not going to help me out. Is there anything else that may help me out about the diagonals? There's 3 things. You told me 1. So they form what? Okay, yep. You guys may not think that helps us out, but we'll wait. And what's the other part that diagonals do in a rhombus? They bisect the angles, they're perpendicular, and they still do what? 15? Bisect each other. So this GI of 8 getting cut into 2 equal pieces of how long? 4 and 4? And what about FH getting cut into pieces of 3 and 3? Diagonals bisect each other. Now the question is, find the length of a side. Somebody let me know why it does not matter what side I pick. Hugh? All sides are equal. Doesn't matter which one I pick. They're all equal, so I'm going to find FI, sure. All right, where are we going now? Why was that so important that the diagonals are perpendicular? Well, what type of triangle did it form? A right triangle where you know 2 sides and trying to find the third? Little something we've been using all year. Didn't teach it to you, but you knew it already. 4? 180 degrees, but these are side lengths. These don't add up to 180. You're talking angles, Rachel. We're talking sides, though. Right triangle, what do I always use if I know 2 sides and trying to find the third? Okay. The whole 180, 360 is for angles only. Angles only. What's the x acting as? A, B, C? C, it's across from the right angle. So x squared and then 3 squared and 4 squared. Okay, 1 side length turns out to be, what do we have? 2? 5. If I gave you a second part to this problem that said, what's the perimeter of the rhombus? What is the perimeter? If one side is 5, what's the perimeter? Why 20? All sides are equal, so all 4 sides would have been 5, adds up to 20. Okay, I'd recommend getting a Chromebook out, your phone out with the answer key up in your group, at least one up in your group, because without a doubt, you could probably finish all this by the time you leave today.